Welcome to lecture 25, encapsulation and abstraction. So, in the previous lecture we talk about the abstract class. So, on the continuation, right. So, we will see one more example, right. So, exactly the real scenario. Suppose I have an abstract class called shape, right. So, under abstract class shape I have an abstract method called draw, right, void draw. So, now let us assume, right, in the real scenario, assume that the implementation is being provided by others, right, unknown by end user. So, now I have the class rectangle, right. So, assume that I have class rectangle which is extending shape, right. So, you have a shape as a base class, right. So, assume that you have shape as a right which is abstract class, and then you are having the derived class which is rectangle, correct. So, now you can see you have an abstract method called draw, and then that is being defined over here in the derived class, right. You call it as a super class. Shape is a super class and rectangle is the subclass, child class or derived class. So, use extends, all these things we had seen. So, now it is printing drawing rectangle, it is printing drawing rectangle. So, now you have assume that you have class circle 1, another class, right. So, you have another class which is extending shape, right. So, you have another class called circle, let us say circle 1, right. So, circle 1 which is extending shape, right. So, here you go. So, there also you have draw, there also you have draw, right. So, let us have a test abstraction 1, right. You have a class which is a driver class, right. You have the main. So, since it is a main, you call test abstraction 1 as the driver class. Let us create an object S, let us create an object S under shape, right. So, let us create an object small s under shape class, right, and then you have the constructor circle 1, right, exactly like the example we had seen, right, bike and Honda 4, right. Under bike you have created an object obj. So, when you have the constructor, yes, it will work, right. So, you are calling s dot draw, right, the object s which is invoking draw, right. So, when it is happening s dot draw, right. So, we know that which method will be called, right. So, we know that which method will be called. So, here you have the derived class, correct. So, here you have the derived class draw circle 1. So, system dot out dot println you have drawing circle, right. So, here the drawing circle will be called, right. So, in this case the drawing circle will be called. So, this will be called, correct. So, when I run the code, so you can see drawing circle will be called, right. So, your object S is under shape, but the reference is in circle 1, right. So, upcasting, you are doing upcasting, you have to do upcasting. So, suppose I put shape S is equal to new, and then here also let us assume it is shape, right. The constructor is also shape, we know, right. You cannot instantiate an object S under the reference shape, right. So, which will throw an error, correct. So, therefore, you are upcasting this, and when you are upcasting, and moreover we know that shape is the abstract class and it contains the abstract method as well. So, therefore, it will go to the derived class called circle 1, or you call it as a subclass circle 1. Under subclass circle 1 you have the method draw, right. So, that will print drawing circle, right. So, when you run the code, you will get the output drawing circle. So, another example, you have an abstract class that can contains constructor, data member, methods, etc., right. So, for example, here abstract class bike, right, abstract class bike, and here it is a constructor and here it is a constructor. So, the constructor has bike is created, right, system dot out dot println bike is created, right. So, this is a constructor, bike is a constructor, and line number 4 you have abstract void run, alright. So, that means you it is a no defined function, right, no defined method, yes, this is abstract method. So, you can define like this. So, in C++ we saw pure virtual function, correct. So, you use the keyword virtual void run equal to 0 semicolon equivalent, right. So, in Java we have abstract void run, right, with semicolon, and then you have a usual method. Void change gear is the usual method. So, the usual method your system.out.println and gear changed, all right. So, that is why still we have not achieved 100% abstraction, right, 100% abstraction has not been achieved. The reason is, this is an example. So, you have, let us say, two methods, one is a constructor, correct. So, one method is abstract method, another one is a non-abstract method. So, here we have 50% abstraction in terms of methods, right. So, now when we have the abstract class bike, so it should be inherited, right. So, that means you have class Honda, that means you have to extend. So, the class Honda which is extending bike. So, now you have the method called run and you have system.out.println and we call it as SOP and running safely, you are printing running safely, right. So, now go to the your driver class. So, here you have the driver class, let us say test abstraction 2. So, you have the main method. Under this main method you have obj which is an object, right. Obj is under bike, bike is a abstract class allocating a memory with a constructor Honda, you are upcasting, right, which is possible. This is absolutely fine. So, this will work. Now, obj, right. So, this object obj will invoke the function, the method run, right. Obj will invoke the method run. So, when it is invoking, so obviously, right, it is abstract method, right. So, that is being defined in the derived class or the subclass. So, the subclass method run will be invoked and running safely will be printed, right, running safely will be printed. Again obj is invoking another method called change gear, right. So, obj is invoking another method called change gear, right. So, when it is invoking change gear, so system.out.println you are getting gear changed, right. So, you are getting gear change gear, all right. So, in this case it will go to the base class, the reason is you are creating an object obj. So, it is overridden, right. So, it will go to the base class, all right, and in the base class you have the gear changed, all right. So, that will be printed, all right. So, this will be printed. So, you are getting the output. So, when you are creating an object obj, right, when you are creating an object obj, you have the constructor, right. So, you have the constructor, you have one print statement. So, bike is created will be printed, right, bike is created will be printed. I hope it is clear, bike is created will be printed. So, that is why you are getting first output bike is created, right. So, next obj when is invoking run, running safely will be printed. So, we are getting the next output running safely, right. And the third case when obj is invoking change gear, right, when obj is invoking change gear, gear changed will be printed, right. So, gear changed will be printed, right. I hope it is clear now, in the sense in the abstract class we can use the constructor, data member, right. Obviously, we had seen several examples of abstract methods, right. So, here you go, we have abstract methods and then the usual method also, right, non-abstract method, right. So, here change gear is the non-abstract method, alright. So, when we run the code, we are getting the output like this. So, now the next concept is interface in Java, right. So, when you want to achieve 100% abstraction, right, it is exactly the abstract that you define in a research paper, right. So, we can do with the help of interface, right. So, it is exactly like a design plan, alright. So, what I am going to do in this paper. So, in a similar way what I am going to do in this program, right. So, I need let us say 15 functions, right, 15 methods. So, these are all the methods I require, right. We assume that you are writing a code or you are competing the programming contest, alright. So, you have to plan. So, when you are planning you will have the set of methods. So, these set of methods I want to use, right. So, that is called the blueprint of a class, right. So, that means I will have the design plan, right. So, it contains that means the interface contains the static constants, right. So, it contains only static constants and abstract methods only. So, it should have the constant. Suppose you are defining int min is equal to 100, right? It is nothing but static constant int min according to the compiler. So, once even though you are not defining, that we are going to see, right, even though we are not defining, so that is considered as constant, the data members. Min is equal to 5, int min equal to 5 in the sense, so that will be constant. And then any method you are defining, which will be the abstract method only, you can define only the abstract methods, right. So, when I am talking about the interface, so this is the mechanism you can achieve the full abstraction, right. So, the interface in Java, so you can achieve 100% abstraction. So, when I am talking, obviously when I am talking about abstract methods in the Java interface, so you do not have any method body. So, we are not defining any, right. So, inside you are not defining, when I am having the abstract, obviously the method will also be abstract. So, you do not have any method body, alright. So, since I said you can achieve 100% abstraction, so now this is going to support your concept multiple inheritance. So, when we talked in terms of class, we have single inheritance or single or simple multi-level inheritance, alright, but whereas we do not have multiple inheritance. When you are using only class, we do not have multiple inheritance. Hierarchical we have, but we do not have the multiple inheritance. So, obviously you do not have hybrid inheritance also, right. So, this is going to support the concept of interface, will support the multiple inheritance in Java. So, the main use of this is to achieve the 100% abstraction, right. So, what is the use of interface, you may ask. So, this will achieve full abstraction, or you call it as a 100% abstraction. So, we can support the functionality of multiple inheritance. So, we are going to see how this is going to support multiple inheritance. If you recall, we have done multiple inheritance in C++, right. So, we have done multiple inheritance in C++, and let us consider in the case of Java, we are going to see how this is going to support the multiple inheritance. So, suppose, so let us consider, we are going to have the keyword call interface, right. We are going to have the keyword call interface, and printable is the name of the interface, alright. This is syntax. You have to use the keyword interface and printable, right. So, which is the name of the interface, and then suppose you are having, alright. So, suppose you are having int min equal to 100 and void print. So, this is a printable.java program. So, according to the compiler, alright. So, according to the compiler, so this is static final int min equal to 100, that means it is a constant even though if you do not define, and similarly void print will be nothing but the abstract, right. So, this is nothing but the abstract void print, alright. This is abstract method according to the compiler. So, that is what this diagram is depicting. So, you may have the data member, assume that you are not putting final, keyword final is nothing but a constant, const in C++, right. So, in the case of an interface, because this is 100% abstraction, so here when you are writing int min is equal to 100, meaning is it is public static final int min equal to 100, and void print function, which is nothing but the abstract function, right. So, in the compiler it will be considered like this, even though if you do not mention, right, even though if you do not mention, in the compiler it will be considered like this. So, with this in mind, alright, so we will see how we are going to use the keywords, right. So, in fact, when we talk about class, one is the super class, another one is a subclass. Class A, let us say it is a super class, class B is a subclass, B is extending A, class B extends A, right. So, class B extends A. So, assume that you have an interface and class is going to inherit interface, possible, right. It is also. So, in that case you have to use the keyword called implements, you have to use the keyword called implements. So, assume that you have the super right class equivalent, you say super interface, right, or simply interface, which is the equivalent to super class, and then you have, let us say, subclass B dash, right. So, the inheritance point of view, you use the keyword implements. So, B dash implements A dash, right. And suppose your base is also interface and derived also interface, that means superclass is the interface A double dash, and derived class, that means a subclass which is also interface B double dash. Now you can say that B double dash extends A double dash, right. So whenever you have the same, right, class, you use extends. Whenever it is different, you use implements, right. So we are going to have implements. So now we will see with an example. So that will be very easier, right. So let us say printable, right. The interface, name of the interface is printable, right. So how do you write? You have the keyword call interface, right. You have the keyword call interface, and then you have the name of the interface is printable. So here you have void print, right. So here you have void print. So now class A6, right. So now you have one class. So one is interface, another one is class, all right. So it's like the scenario will be like this, all right. So scenario will be like this. So in that case, right, so you have interface A dash and class B dash. So A dash is nothing but printable and B dash is nothing but A6, right. So class A6 implements printable, class A6 implements printable. So here you have, so you have print method, right. So obviously when I put void print, which is nothing but abstract, right, it is equivalent to abstract. So any method you are writing inside the interface is the abstract method. We know the definition of abstract method, right. So now based on that, so let us consider you have in the subclass print, so you have system.out.println learning interface, let us say at IITR, learning interface at IITR, that is the print statement that you are going to give. So now I have created an object obj, right, under the class A6, right, under the class A6, dynamically allocating a memory and my constructor is A6, all right. So now the object obj under class A6 which is invoking print, all right. So when it is invoking print, so naturally, right, so this is the interface 100% abstraction, obviously line number 2 should be overridden. So when it is overriding, it is going to this particular method, right, void print method, and it is printing learning interface at IITR, right, it is printing learning interface at IITR. So when I run this code, right, when I run this code, so compilation a6.java is the name of the function, and when I run this code, I will get learning interface at IITR, right. So you are getting the output, right. So this is how simple case what we have studied from this diagram, right. So you see this scenario, right, printable is A dash and A6 is B dash, right. So class B dash implements A dash, that is what you are writing, class A6 implements printable. So here you have interface keyword, right. So here you have interface keyword and printable is the name of the interface, and void, it contains void print, and then here line number 5 is a syntax, class A6 implements printable, right. So when you have this, you can see how do you achieve multiple inheritance in Java, right. How do you achieve multiple inheritance in Java, right. So based on the previous example, now you are going one step ahead. So suppose I have, let us say, interface, right, like this, and then the class is going to use or going to implements interface 1 and interface 2, right. So we can achieve the multiple inheritance. So when I define in terms of interface, let us say one interface I am defining another interface, so I can have this multiple inheritance. In fact, I mean in Java the diamond problem will be solved. Assume that hierarchical is not a problem. Suppose I have class A, so this can be inherited, right, by class B and class C, right. So this was not a problem, right, whereas this is a problem. When you have class C and class D, this is possible in C++, but this is not possible. So that means this particular part. So the shape is looking like a diamond, so you call it as a diamond problem. So the interface will solve this diamond problem, right. So when you have interface 1 and interface 2, and then the class can implement, right. Class implements interface 1 comma interface 2, and if you are using all interface, interface extends. Okay, we use extends if it is the same, right. If both are same, yes, all are interface. So, interface extends interface 1 and interface 2, right. So, that is what the meaning over here. Let us see this with an example, right. So, we call it as multiple inheritance in Java, right. So, let us have interface printable, alright. So, let us have one interface called printable. I simply write P, P stands for printable, and another interface called showable, right. Both are interface. So, I will write I1 and I2, right. One is I1 interface 1, another one is I2 showable. So, now the class A7. So, now the class A7 implements printable and showable, right. Class A7 implements printable and showable. Class A7 implements printable and showable, right. So, in fact, when you look interface printable, you have one abstract method void print. You have one abstract method called void print, and showable you have method called show, right, abstract method, right. So, you interface means the method is abstract, print and show. So, this has to be extended in A7, class A7, that means we have to define this. So, public void print, you have system.out.println one statement, let us say the statement is hi we are learning, alright, hi we are learning, and another statement show, another function, another method show, alright. So, the show method you have a print statement multiple inheritance through Java interface at IITR, right, multiple inheritance through Java interface at IITR, right. So, now we are creating an object obj, right. Now, the scenario is clear, right. So, here you have the print function, print method which is the abstract method, and show method, and A7 contains both, and then you are defining also, alright. So, you are defining show also, you are defining show also. So, now assume that you are creating an object obj, right. So, let us assume that you are creating an object obj. So, obj is under A7, right. I am creating an object obj whose reference is also A7, right. So, now this obj is invoking print, right. Obviously, it will be overridden and this should be printed first, hi we are learning, right. And then next obj is invoking show, right. So, next obj is invoking show, right. So, when it is invoking show, if you look at the class A7, right, if you look at class A7, so I am finding, right, one print statement multiple inheritance through Java interface at IITR, right. So, this will be called, and when I run the code, I have to get the output like this, right. So, I have to get the output like this. So, I am compiling javac A7.java, then next running. So, you can see the output over here, right. We are learning multiple inheritance through Java interface at IITR. So, that will be printed, right. So, the code is working fine and you can see, right. So, the scenario we had seen. So, we have printable and showable. Now, in line number 9, the first time we are seeing class A7 implements printable comma showable. So, in fact, if you look C++, we have done this, right. So, C++, I mean we can write both printable and showable as a class, right. So, assume that what do? You replace interface with class or abstract class, right, and similarly this you will get an error, right. So, the overridden is not possible whether you put simply class or abstract class, right, it will give an error because of line number 9. So, how do you achieve this? Put interface instead of class, use interface. So, when you are using interface, right. So, now I can write the syntax in line number 9. So, the class A7 implements printable and showable, right. The class A7 implements printable and showable, right. So, we know that, right. So, we know when you are using only class, you cannot have the multiple inheritance, but whereas it is possible by interface only, right. So, the reason is the interface, right, which is supporting the, right, I mean to say the multiple inheritance concept is supported in the case of interface, because I mean here there is no ambiguity, right, as implementation is being provided by the implementation class, right. So, therefore, you can have the multiple inheritance concept. So, what we had seen like this. Okay. So, maybe I will conclude with this particular example. So, it is similar, right, you have a printable interface and showable interface and then A8, right. So, this is I1 and this is I2 and in fact, this is class. So, this class implements printable and showable, alright. So, here I have both print statement. In the previous example, I have one print and one show, right. So, here I have both are print statement, right, and then here it is implementing both printable and showable. A8 is implementing both printable and showable, and you have void print statement system.out.println CSN 103 at IITR is being printed. So, now I am creating an object obj under A8, right, dynamically allocating memory with the constructor A8, and when object obj under A8 invoke the print method, right. So, that will print CSN 103 at IITR, right. So, this you will get as an output. When I run the code, I will get this as an output, right. So, in this chapter, so we talked about extensively little bit abstract class, and now you know what do you mean by interface, right. So, in the whole chapter we have seen encapsulation, right, how do you use the getter and setter method, how do you use the access modifiers, right, and then how to prevent, how to give a security for certain data members, and how can I access those private data members from outside the class with the help of setter and getter methods, right. So, then later we have talked about abstraction, right, which is 0 to 100% we can achieve, right, with the help of abstract class in Java, pure virtual function in C++, and finally, we have concluded with the interface, right. With this I conclude this class. Thank you.